Good evening. Week 3, Tuesday. Today is the last lecture that I'm going to do on eccentric buckling. Okay, repeat again. I'm going to do the last lecture on eccentric buckling, and I'm going to post the homework for eccentric buckling tomorrow. Okay, so let's quickly recap about eccentric buckling. So eccentric buckling, I post the notes that how we do the derivation, but I'm not going to do it because it's going to waste not waste, but we're going to spend like 45 minutes writing out equation. But rather than that, I'm going to show you how we're going to apply the equation for eccentric buckling. Okay, so let's look at eccentric buckling. So just to quickly recap, so for eccentric buckling, the configuration looks like this. Okay, so I'm going to sketch what do we mean by eccentric buckling. So we have a beam, and then we have our centroid. Okay. So I'll write this. This is our centroid. And then we have a applied load. And we have applied load offset from the centroid. Okay, so we have one load applied here. And then we have a couple on the other side. Okay, it's not allowing me to do something. All right. So you can see that the applied force P and P prime has a certain distance away from the centroid. And this distance, okay, this distance over here, and this distance over here is what we call E. And the distance from here to here, okay, is C. Okay, so from the centroid to the extreme edge of the structure, we call it C. Okay. And in eccentric buckling, as I said, I did not derive it. That's why you don't see it. Okay, there's a disadvantage of not deriving. In eccentric buckling, okay, maximum deflection which is our Y max, occurs when X is equal to L divided by 2. Okay, so if I were to draw the transformation, this is our Y, and this is our X. Okay, right. Okay, so the formula that we are going to focus on is very different from centric buckling. Okay, because in eccentric buckling, we are very concerned about Y max. So Y max is equal to E. So now you know what is E all about now, right? And then here, secant bracket square root P over EI multiplied by L over 2. Okay, the whole thing cosine, secant, sorry, minus 1. Or if I'm going to rewrite this, okay? Or in case some of you don't know what is a secant, this is equal to E. And then all you do is 1 over cosine square root. Okay, let me square root P over EI L over 2. Okay, and then you minus 1. And always remember, I think I say this in class the last time, this term over here is in radians. Okay, this term over here is in radians. A lot of times students forget that this is radian, and then when they when they do the calculation, we see the problem. Okay, now y max can also be written in a different form. Okay, so take note that y max, okay, in another form. Okay, so in terms of critical stress, y max can also be E bracket secant, right? And then all we need to do is we square root P over PCR pi squared over L squared. Okay, and then this whole thing multiplied by L over 2. The L over 2 is outside. Okay, and then minus 1. So this is another form. Okay, so if we were to rewrite this form, right, is equal to E secant. Okay, then I'll take out the pi over 2. You introduce the L over 2 inside there. You're left with P over critical minus 1. Okay. So just to define some some terms, okay, so we know that E is the eccentric load distance. And then P is our applied load, right? So we know what E is our Young's modulus. And we also know what is I. I is our second moment of area. And what else? Yep, that's it. And PCR, or critical load, can be written as pi squared over L squared EI. Okay. And you have seen this term before, or it can be equal to pi squared over LE squared EI. Okay, we have seen this term in, so this is also the same as centric Buckley. Okay. So from here, another term that we use is the, so the first thing we do in eccentric buckling is we are concerned with the maximum deflection. Okay, and next is the stress max. Okay. Okay, so stress max will be equal to P over A. So this is 1 plus by EC over R squared. And then we have the term multiplied by secant, okay? And then pi over 2 square root P over PCR, 2 brackets, okay? First bracket, second bracket, and then a square bracket. So that's the maximum stress. And we have to ensure that we had note that we have to ensure that the maximum stress has to be less than stress capital Y, where stress capital Y is a U stress. Okay. So the only term that we don't know is C, is the distance, the furthest distance away. From the centroid. Okay, so that's why this is where the centroid is. This is C. Okay, that is the distance furthest away from the centroid. Now we also know, right, that stress max can be written in a different form. Can be written as P over A 1 plus by EC over R squared, and then secant, and then over here you have L over 2R, and then square root P over EA, and then you close the term. Okay, so for this case, the term that is not defined, oh, there's another term that I did not define, I do apologize, is we have R, which is correspond to the radius of gyration. And we know that note that I is equal to AR squared, right? And then A is the cross sectional area. Okay. So all these are just numbers to look at. So what will happen is in the term test, I will provide these formulas that I'm going to draw in a box. Okay. So I don't expect you to memorize all these. I will provide all this. Okay. So this formula I'll provide. Another formula I'll provide is this. Okay. Another formula I'll provide. And so all these that are drawn in box, I will provide them as formula, but you have to know how to apply them. Okay. So that's where we are going next into our lecture, is how are we going to apply them? And applying them is it's not difficult. Okay. You have to know which second moment of area to take. Okay. And I'm going to show you a few examples. We're going to do 3 examples. So if you go to Avenue to Learn, I hope I did upload on Avenue to Learn. I think I did. So if you go to Avenue to Learn, I've uploaded the questions that I'll be using for today. It's under week 3. Okay, so these are the, if you click on it, okay, so these are the questions that we are attempting today. Okay, so let's do example number 1. Okay, so the first example that we'll try to attempt is this one. And I'll get the diagram